Hello everyone. So today we are going to conduct an experiment called study of magic T and extraction of its S parameters. So in this experiment, we'll determine the VSWR, isolation loss, coupling coefficients. Okay, and we determine the scattering matrix of the magic T. Okay, so we have discussed E plane T and H plane T in the previous experiment. Okay, so in this experiment, so we are going to use magic T. So what is this magic T means? So it's a combination of H plane T and the E plane T. Okay, so we can either use this as H plane T or we can use this as E plane T. Okay, so here this magic T is also called as hybrid T. It consists of 4 ports. Okay, port 1, port 2, port 3, port 4. Okay, so this is E arm and this is H arm. Okay, so we can use this either E plane T by using this arm, or we can use it as H plane by using this arm. Okay, so there is no these port 3 and port 4 are completely isolation ports. That means so there will be no power flow between port 3 and port 4 or port 4 to port 3. Okay, so first connect the detector mount and generate the mode and set the output to the maximum amplitude and measure the voltage. So here the voltage is 2.36 volt. So that is our voltage V1. So this is the experimental setup. So connect the magic T. So connect port 1 to the input and port 2, port 3, port 4 to the match termination. So now I have connected the magic T. So the port 1 is connected to the input port and other remaining ports are connected to the match termination. Okay, so now the mode is generated. So now I need to find the VSWR in this condition. So in order to find the VSWR, I need to measure the minimum voltage and the maximum voltage. So to measure that, so rotate this SLC knob, okay, and observe the voltage. So the voltage is getting reduced. Okay. So this is the minimum voltage, 76.8 millivolt. So similarly continue this rotation in order to obtain the maximum voltage. Okay, so I got 153, 155. So that is a Vmax. So next I need to measure the voltages. V1 is already measured by connecting the detector mount. So in order to measure the V2 and V3 and V4 and V5, okay, so I need to measure these voltages. So observe this figure D. Okay, so here port 1 is input port 3 and port 4 are connected to the match termination. So the detector is connected to the port 2. Okay, and we can measure the voltage V2. So therefore so remove the match termination which is connected to the port 2 and connect the detector mount to that port and measure the voltage V2. So observe here. So I have removed the match termination which was connected to the port 2. So in that place I have connected the detector mount. From detector mount I have connected to the CRO. So now measure the voltage V2. Okay, so here the peak to peak voltage is 222 millivolt. So that is our voltage V2. So now I need to connect the detector to the port 3 in order to measure the voltage V4. Okay, so I have connected the detector to the port 3. Okay, and I need to measure the voltage V4. So voltage here is 2.36 volt. That is our V4. So in order to find the VSWR for port 3 as input, okay, so do this connection, that is give port 3 to the input port and connect the match termination to the remaining all other ports. So here you can observe, so I have connected the port 3 to the input and I have connected the match termination to all other ports. Okay, so now I have connected the CRO probe to the SLC. Okay, so now in order to find the VSWR, so rotate this slotted line carriage knob and find the Vmax and V minimum. So now voltage is getting decreased. So this is a minimum voltage. So now continue the rotation in order to obtain the Vmax. So I got 120 millivolt is the Vmax. So similarly, to measure the voltage V3, so we need to connect the port 3 to the input. So now port 3 is connected to the input. So now replace the match termination of port 1 and connect the tune detector in order to measure the voltage V3. I have connected the detector to the port 1 and measure the voltage V3. So the peak to peak voltage here is 2.38 volt, that is voltage V3. So in order to find the voltage V5, so we need to connect the detector to the port 4 when port 3 is connected to the input port. Okay. So observe here, so detector is connected to the port 4. So this is the port 4, this is port 3 is connected to the input port. Port 1 and port 2 are connected to the match termination. So now observe the voltage V5. So peak to peak voltage here is 52 millivolt, that is our voltage V5. So these are the calculations part. So I have measured the voltages and VSWR values. So I have calculated the isolation by substituting the voltage values. Similarly, I have calculated the coupling coefficients and VSWR for port 1 as input and port 3 as input, and corresponding reflection coefficients to find the S parameters. So and these are the different S parameters of Magic T. Okay, thank you.